Okay, welcome to chapter 1, section 4. This is the first video. We're going to talk about some definitions and perimeter on a coordinate plane. Sorry for the lighting, kind of looks like I have a halo above me, but I assure you I don't think I do. Anyway, let me switch my screen. We need to be turning to page 30 and 31 in our textbook. This is chapter 1, section 4. We're going to talk about the types of polygons and their perimeters. You, right now, need to copy down the core concept at the top of page 30 and the chart on the left of the page. So you probably want to pause now to make sure you do that. When you get back, I'm actually skipping ahead to numbers 3 and 5. You're going to do 1 and 2 and then 4 and 6. So why don't you, actually, you're going to take some notes right now. So the chart that's on the left of that page, that gives you the number of sides and the vocabulary words. You've seen triangle, you've seen quadrilateral, you've seen pentagon before. The rest of them might be new to you, they might not be new to you. Now, one thing about convex versus concave to help you answer what type of, or rather, whether a polygon is convex or concave. I think the easiest way that I know is that concave polygons have a cave inside them. Convex polygons don't. So in other words, if there's a side of the polygon that's caved inward, could be any side, cave in, then it's concave. Otherwise, it's convex, okay? Now, you should go ahead and on page 30, do numbers 1 and 2, and then answer them on Edpuzzle, okay? And when you're back, we are going to copy down the box at the top of page 31. Has the perimeter and area of a triangle, square, and a rectangle. You want to get used to the different notations there. So pause and copy that down. And then I'm going to move on to number 3. Now, I used graph paper. You don't have to. But I thought, well, if I'm making a video, I might as well make it as neat as possible. And if you've been in my class for a while now, you might know that I am not the neatest, but I try to be organized. Okay. So we want to find the perimeter of a polygon with the given vertices. So I'm reading number 3 right now with my eyes, and I'm thinking, what kind of Cartesian XY plane do I want to make? Looks like -5 to 5 will work. So D is at -3, 2. Okay. Now, since I am, well, you know what I'm going to do? I was going to say I'm going to make points and label the points, and you do need to in general, but right now, since we're just putting points on there and I'm staying as organized as possible, I'm going to make my tick marks so that I can see where everything is easily. And actually, now that I've made my tick marks, I'm going to put the coordinates next to the point to check my work. Probably a good thing if you are easily confused by a bunch of numbers at the same time, which is just a normal thing. All right, so I have a polygon, and it looks like it is in the shape of a triangle. So I need to find the perimeter. Well, fortunately, the book gave me a nice one. Hopefully you have a nice one next. But I can actually just find this side, the distance of this side, pretty easily. So it's 1, 2, 3, 4, 5, 6, 7, right? -3 to 4 is 7. And let's see, this side looks like it's 2, 3, 4, 5 boxes. 2 to -3, that makes sense. 5 boxes. So far I know I'm going to add 7 plus 5. And so now I need to find this one. So I actually have 2 options because I'm lucky in this case. However, I'm going to go with the option that's going to work no matter what, and that is not the Pythagorean theorem. That is the distance formula. So I want to know the distance from D to F. And if you remember from the previous section, we talk about saying the square root of the difference of the x's, so 4 minus, look at me, 4 minus negative 3 squared. See how I did minus negative 3? Plus the difference of the y's, negative 3 minus 2 squared, okay? Notice that this is actually a subtraction problem. Look at where my leftmost finger is. All right, 7 squared is 49, and negative 5 squared is 25. So we're talking the square root of 60 plus 14. We're talking about the square root of 74, which in Algebra 2 is sometimes okay to leave it like that, but I better figure out what it is by using my trusty calculator. And if you have a scientific or a graphing calculator, you should use it too. Easier than just going on a Desmos for something like this. I'm going to round to the nearest 100, which means that the 0 doesn't round up, so I just need to write 8.6. All right, so this side is 8.6, which means the perimeter is 7 plus 5 plus 8.6, or 12 plus 8.6. So the perimeter is about, and we use squiggly lines for about because we are estimating 20.6 units. Okay, so plot your points, be neat, skip difficult steps where you can. Easy, you don't need to use the distance formula. You can if you want to. Don't need to use the distance formula. You can if you want to. Definitely want to use the distance formula. You could use the Pythagorean theorem here, but you probably have practiced with that and not with this. And make sure you stay nice and organized. That's your answer. You are going to go ahead and do number 4 right now. Put your answer in Edpuzzle. I'm going to turn the page and do number 5 with you. So I'm taking a quick scan of all the numbers one more time, and I think doing the same type of Cartesian plane going 5 to negative 5 will work. So I'm just estimating, by the way, kids. I can always change it if I need to. You should be writing in pencil, so it shouldn't be difficult. So I have k at negative 1. Oops, that's wrong already. Negative 1, comma 1. I have L at 4, comma 1. I have M at 2, negative 2. Oof, alrighty. And then I have N at negative 3, negative 2. Oh, okay. All right. So now I'm putting in my, notice that I didn't write tick marks at this time. So I am absolutely putting in my coordinates and double checking as I do it. I'm not just copying down. I'm making sure this is actually negative 1, 1. I'm making sure this is actually 4, 1. I'm making sure that this is actually 2, negative 2. Okay, you're not just blindly copying things down. You're using your brain and your eyeballs to check your work. Okay, and I see it wasn't that hard. You probably did it faster than I said it. Okay, well, we got some good size here. Let's see. So K to L is 5. And just to check, M to N is also 5. All right, so let's use the distance formula to find LM. Okay, we're talking about the difference of the x's squared plus the difference of the y's squared. Negative 2 squared is 4, negative 3 squared is 9, and we are talking about the square root of 13. Trusty calculator. Looks like it's about 3.61. Don't forget your squiggly lines for about. So now this is about 3.61. Let's like use our better judgment here, children. This was 5, this was 5. This distance is 3.61 units. Don't you think this distance is also going to be 3.61 units? I mean, let's see, we're talking about a line, segment that goes 1, 2, 3 up and 2 over. A line segment that goes 1, 2, 3 up and 2 over. So I'm going to estimate that this is about 3.61 as well. You can check my work, or let's use some common sense here. I would love common sense. All right, so now we have something that is 5 plus 5 plus 3.61 plus 3.61. So 10 plus times 3.61, 17.22. Don't forget to write down units, right? We don't know if it's meters, centimeters, inches, what. So there we go. All right, so number 6, go ahead, do it now. Put your answer into Edpuzzle for the perimeter, and we'll be back for a video on area. Don't forget that you need to go to the end of this video to get credit.